Hi and welcome. In this video, we're going to implement the drag and curve. I'm using D programming language and Raylib graphics library. The code should be quite similar if you're using another language. The drag and curve is a member of self-similar fractal curves. The curve is built recursively by following these simple steps. At first, we start with a single line. Then we need to divide the length of the line by a certain scaling factor and rotate the line by minus 45 degrees. And we need to do the same with the second segment, but this time we rotate it by 5 times 45 degrees. And so on and so forth, infinitely many times. In the end, we should get a dragon-like shape. Alright, let's implement all of this. I have already imported the necessary math functions and created a basic window. It does not display anything for now. I also have created a drag and curve function, which I call from the main loop. The function takes the starting x and y position of a line, the segment length, the angle, and the number of recursive iterations. And the scaling factor we're going to use is the square root of 2. The first thing we're going to do is limit the number of iterations by exiting from the function once the limit is less than or equal to 0. But before we exit, we need to draw the resulting line segment. I'm going to use the drawLineX function from the Raylib library. It takes the starting point, the ending point of a line, the thickness, and the color as arguments. The starting point is just the x and y coordinates. The ending point is the original position plus the segment length times the rotation factor, which is the cosine and sine of our angle. Now comes the recursive part. We need to call the function itself twice, since the curve is divided into 2 symmetrical parts. For the first case, it will take the original x and y coordinates, and the new length is the old length divided by the scaling factor. The new angle is the old angle minus 45 degrees, which is pi over 4, and we should decrement the limit by 1. For the second case, we're working with the ending point of our line. Therefore, we need to add the segment length to the original coordinates and multiply by the rotation factor. The new length is the old one divided by the scaling factor, and the new angle is the old angle plus 5 pi over 4, and we should decrement the limit by 1 as well. That's it, we're done. Now pass in the arguments to the drag and curve function, compile and run your code. To make it interactive, let's add the following features. Zooming in, zooming out, moving left, right, up and down. To implement all of this, we need to create a camera struct. It should contain the x and y position, the segment length that we will adjust for our own use, and the default segment length, so we could reset it to the original size. We also need a constructor to initialize all of these variables, and we need to create a camera instance in the main function. So let's go ahead and do that. The idea is simple. By moving up or down, left or right, we adjust the x and y coordinates respectively. To zoom in or out, we adjust the segment length by a certain margin. Compile and run. Now you should be able to explore the drag and curve fractal more easily. Try to tweak the variables like angle or length to see what happens. For instance, if we change the angle in the drag and curve function and replace it by pi over 4, we get something like a Levy C curve. Amazing, right? The drag and curve is somewhat similar to the Levy C curve, which we will implement in the future videos using the L system. The L system is a special method that stores instructions in a textual format using alphabetic symbols. Alright, that's it. Have a nice day.